Welcome to my video lessons. The main objective of this session is in this video I'm going to explain about the photovoltaic cell. What is a photovoltaic cell and what is the principle of it, and LED light emitting diode, construction and working principle of the LED and a liquid crystal display. What is LCD, how it is constructed, and what is the working principle of LCD and its applications. All we will discuss in this session. Before entering into this today's topic, just I will recall the previous session. What I explained in this previous session is special semiconductor devices. What are the special semiconductor devices means? Is a type of semiconductor devices specially designed with proper doping depending on the requirement of applications. Right, these special semiconductor devices are used for different applications, particular applications. Examples of special semiconductor devices are phototransistor, photodiode, and UJT varactor diode. These all are comes under special semiconductor devices. What is a varactor diode means? It is also called a variable capacitor. That means this is a type of PN diode. It operates in the reverse bias. It operates in the reverse bias. Whenever the reverse voltage is applied, the capacitance will be varied. That means when the reverse voltage is applied, means the depletion width of the junction will be increasing. With this, the capacitance decreases, and the relation between the capacitance and the width of the depletion region is inversely proportional. So, with the applied reverse voltage, the capacitance is varied. That is about the varactor diode. Variable, also called variable capacitor. The capacitance can be varied. Generally, these are used in place of mechanical variation of the capacitances. And next, I also explained about the UJT, uni-junction transistor. The name itself, it is a type of transistor, and the number of junctions it has is only one. And it is a like a transistor. It also has three terminals, and that is emitter, base 1 and base 2. Base 1 and base 2. Based on the applied voltage on the base emitter, this will be varied. Right, we also discussed about the characteristics of UJT and these things. Next is photodiode and phototransistor. That means photo indicates it is working on the photons. That means based on the light energy. This photodiode, a type of diode, and it is working on photons. And photo transistor, it is a type of transistor. Right here also it is that means this photodiode and phototransistor converts the light energy into the electrical energy. Type of diode and type of transistors, but here the input is light energy. It converts light energy into the electrical energy. Photodiode has two terminals, and there is a small bit is constructed means at the PN junction there will be a small window. On this window the light will be false, and here the doping levels are also different. Whenever the photons whenever the light emits on this junction through a small window, and there will be a electron hole being generation. That means recombination takes place. With this, the reverse current increases. This is about the photodiode. That means the reverse current is proportional to the applied light energy. Light energy. This is about the photodiode. And the next one is the photo transistor. What is a photo transistor? Means it is a type of transistor. It is almost similar to the general transistor, conventional transistor. That means here also it has three terminals, emitter, base, collector. But what is the difference with this photo transistor with the conventional transistor is there is no electrical conductivity with the base emitter, the base terminal. At the base, the light will falls on the collector base junction. Based on this light intensity, the base current will be varied. That will be amplified, and it will produce at the collector. That means this phototransistor also converts the light energy into the electrical energy. This is about the phototransistor. Next, now we will enter into our today's topic. Here the main head is photovoltaic cell. It is a cell, right? Photovoltaic, and it is operating on the light. This photovoltaic cell generally also it is also called a solar cell. We all are well known with what is a solar cell. Generally, the solar cell converts the sun energy into the electrical energy, sunlight into electrical energy. Right? This already we know. And how what is the working principle of it? We will discuss. This voltaic cell is an electronic component that generates electricity when exposed to photons or particles of light. It is a special type of semiconductor device. It generates electricity whenever the light falls on it. This effect is called photovoltaic effect. This conversion of light energy into the electrical energy, is called uh, photovoltaic effect. And the device used for this is called photovoltaic cell. It is also called solar cell. This photovoltaic cell is a conversion of sunlight into the electricity. In photoelectric cell, it is defined as a device whose electrical characteristics such as current, voltage or resistance vary when exposed to light. Whenever there is light on this device, there will be a variation in the parameters like current, voltage and resistance. That means the current, voltage and resistance of this photovoltaic cell depends on the illumination of the light. Uh, the operation of photovoltaic cell requires three basic attributes. One is the absorption of the light, whatever may be the light falling, the absorption of the light, and generating either electron voltage or excitations. That means whenever the light falls on this device, it generates the electron voltage or excitation of electrons will be takes place. The next step in the next the separation of charge carriers of opposite types, and the it separates the extraction of those carriers to an external circuit. Whenever light falls, there will be a generation of electron hole pairs, and after that, the charge carriers, separation of charge carriers will be taken place. Then the separate extraction of these carriers to an external circuit. These carriers will be moved to the negative towards to the terminals. This is the construction of the photovoltaic cell. See here it is a P and N type semiconductors. P type this is a P type semiconductor and N doped silicon, and this is P type, and there will be a PN junction. There will be a PN junction. This is a positive electrode, and here it is a negative electrode. That means here but there will be a bulb is connected between the positive and negative electrodes. Whenever there is a sunlight on this junction, photons at this junction, that means electron voltage generation will be takes place. After that, the extraction of this will be taken place. Then current will be flows through this connected device. In a photovoltaic cell, semiconducting materials in the PV cell are doped to form PN structure as an internal electric field. How it is means semiconductor materials in this cell are doped to form PN section, PN structure, that is PN junction. It has an internal electric field. Whenever the sunlight hits the cell, the photons in light excite some of the electrons in the semiconductors to become electron hole pairs. That means whenever there will be a light on this light fall on this junction, the photons in the light, this light energy has photons. It excites some of the electrons in the semiconductor. That means it become electron hole pairs. Generation of electron hole pairs takes place. Since there is an internal electric field, these pairs are induced to separate because of internal electric field. These pairs are used to separate. As a consequence, the electrons move to the negative electrode while the holes move to the positive electrode. With this, a conducting wire connects the negative electrode, the load, and the positive in series. Now, the electrons move to the negative electrode while the holes move to the positive electrode. With this, an electric current is generated to supply the external load. That means, what is the principle of this photovoltaic cell? Whenever there is a light fall on the junction, the photons in the light excites the electrons. With this, electron hole pair generation will be takes place. These generated electron hole pairs they will be induced to separate due to the internal electric field. These plates are induced to separate, and the electrons move with the separation. The electrons are moved to the negative electrode, and the holes are moving to the positive electrode. With this, the electric current is generated to supply the external load. This is the working of photovoltaic cell. And next one is the light emitting diode. We are well known with this word LED. Everywhere we can find this device, semiconductor device. It is a smart tiny device with the indication of light. And always nowadays in our houses, everywhere, and that means television indications, power on indicators are almost LEDs indicators. Now, what is a light emitting diode? The name itself, light emitting, it is a type of diode. It is emitting the light. That is, what is LED means? It is a type of diode. It emits the light. See, how it emits the light, we will discuss now. Here, the lighting emitting diode is a special type of diode, as they have very similar electrical characteristics to a PN junction. It is similar to a PN junction with similar varying parameters. What are the differences? We will see. LED will pass currents in its forward direction but block the flow of current in the reverse direction. What are the similarities between the LED and the ordinary PN junction means? This PN junction diode, we know that it conducts in the forward bias and it blocks the current in the reverse bias. Now, the LED also has the same principle. It conducts in the current will be flows in the forward bias and there will be no current in the reverse bias. The same principle will be applied in this LED. Light-emitting diodes are made from a very thin layer of fairly heavily doped semiconductor materials. The doping levels of LED is heavily doped, and depending on the semiconductor material used, the amount of doping, when forward biased, an LED will emit a colored light at a particular spectral wavelength. Right, and we have seen, you might have seen many LEDs with different colors, green, red, yellow, white, all these. See how these are different colors means depending upon the used semiconductor material as well as the doping levels of it, the emitting light will be vary. The light at a particular spectral wavelength. When the diode is forward biased, the electrons from the semiconductor's conduction band combine with the holes from the valence band and valence band. And then whenever the diode is forward biased, we know the PN junction with forward bias means anode is connected to the positive and cathode is connected to the negative. And this, whenever this LED is forward biased, electrons from the semiconductors, that means electrons are moving from conduction band with the to the holes from the valence band. Semiconductor conduction band recombine with the holes from the valence band. With this, whenever there is a movement of electrons from conduction band to valence band, there will be some release of energy. That energy is to produce photons which emit a light. That energy is in the form of contains photons that is in the form of light. Because of this thin layer, a reasonable number of these photons can leave the junction and radiate away, producing a colored light. Already we know that it is a very thin material. LED is very thin layer of fairly heavily doped. Because of the thin layer, a reasonable number of these photons can leave the junction and radiate away, producing a colored light. That means a forward biased direction LED light emitting diodes are semiconductor device that converts electrical energy into the light energy. That means what is an LED? LED light emitting diode is a special type of semiconductor diode. It emits the light. It converts electrical energy into the light energy whenever it is in the forward bias. That means LED works only in the forward bias. It converts electrical energy into the light energy. This is what is a LED. Now we will see the construction of a LED. See here, we know that an LED is a diode, a type of diode. It has two elements, anode and cathode. Anode and cathode. See here, and there will be reflective cavity. Reflective cavity. This is a semiconductor die. Actually, there is semiconductor die, semiconductor material. There will be formation of this junction. This is reflective cavity and wire bond. Epoxy lens or case to emit the light. There is a flat response. See this semiconductor ray, that means the light will be produced at this part. There is a reflective cavity. Here is a flat spot to indicate the terminal. See, the construction of LED is very different from a normal silicon diode. The PN junction of an LED is surrounded by a transparent and hard plastic epoxy resin, the hemispherical shaped cell. See here, this is bounded and this material is placed in a epoxy lens case to emit the light. Surrounded by a transparent, and that means it is emitting the light, so definitely the material should be transparent. Hard plastic epoxy resins and hemispherical shaped cell. The shape it here is hemispherical and body which affects the LED from both vibration and shock. An LED junction does not actually emit that much light. So the epoxy resin body is constructed in such a way that the photons of light emitted by the junction are reflected away from the surrounding substrate base to which the diode is attached. See here, whenever the photons energy is not that much efficient to emit the light in all. That is the reason this reflected material will be used to reflect the light in all the directions. Does not this junction does not emit that much of light. Due to this, epoxy resin body is constructed in such a way that the photons of light, whatever may be the light generated emitted with the photons at the junction, are reflected away from the surrounding substrate base. Yeah, how it is constructed means there will be definitely a reflection, and for the exposure to emit the light, how it is molded means hard plastic epoxy with hemispherical shape, which itself acts like a lens concentrating the amount of light. This is why the emitting light appears to the brightest at the top of the LED. That means because of this photons of light emitted by the junction are reflected away from the surrounding substrate base to which the diode is attached and are focused upwards to the dome top of the LED. That means the emitted light will be focused upwards. That is the reason the light will be more at the top of the lens, at the brightest at the top of the LED. Not all LEDs are made with a hemispherical shape. Generally, the shape of this LEDs are hemispherical, but not all are not in the same. Some indication LEDs have rectangular or the cylindrical shaped construction that has a flat surface on top. Generally, LEDs are manufactured with two legs protruding from the bottom of the body. One is anode and cathode. This already we know. For identification of this cathode, there will be a notch or flat spot on the body. See, there are the typical, what are the materials used for LED for illumination of light in colors, different colors. Here, suppose the material is a gallium arsenide, the color is infrared. The wavelength of this light is here 850 to 940 nanometers, and forward voltage should be of 1.2 volts. Gallium arsenide Phosphorus, the wavelength of it is 630 to 690 into 660 nanometers. The color will be red. If it is the wavelength of this is 605, light is 605 to 620 nanometers, means the color of this LED is amber. Operating voltage should be 2 volts. And like this silicon and this the wavelength is 432 505 nanometers and blue. So generally rarely we will found this blue and then regularly we will see this red, yellow and green and white colors. Working principle of the LED. How this LED emits the light. The working principle of the LED engineered by is based on the quantum theory. The quantum theory says that when the electron comes down from the higher energy level to the lower energy level, that means whenever the diode is in forward bias, already said that the covalent electrons in the covalent bond are moving to the valence band. That means the electrons are moving from higher energy level to the lower energy level. The energy emits from the photon. That energy will be emitted in the form of photon. The photon energy is equal to the energy gap between these two energy levels. And this photon energy is when the electron is moving from the conduction higher energy level to the lower energy level. That means it is losing some energy. That energy here is called photon energy. This photon energy is equal to the gap between this covalent band and the valency band. If the PN junction diode is in the forward bias, then the current flows through the diode. Right? This is a PN and semiconductor phase, and this is PN junction LED connection, and the light is empty. See here. This is the convection band and this is the valence band. Whenever electron is moving from, this is the energy gap, forbidden band between these two. And here the electron is moving from convection band to the valency band. Convection band to the valency band. So that means in the forward bias, the electron is moving from N to P material and moves P to M. So whenever the electron is moving from the conduction at higher energy level to the lower energy level, it loses some energy that is in the form of photon. That is a photon energy. That energy is depending on this forbidden energy gap. The flow of current in the semiconductor is caused by both the flow of holes in the opposite direction of current and the flow of electrons in the direction of the current. This already we know that whenever the diode is in the forward bias, electrons are moving from N to P type material and holes are from P to N type material. Hence, there will be recombination due to flow of these charge carriers. The recombination indicates that the electrons in the conduction band jump down to the valency band. Right? When the electrons jump from one band to another band, the electrons will emit the electromagnetic energy in the form of photons, and that photon energy is equal to the forbidden energy. The energy of the photons, what is the energy levels of these photons is, it is equal to the product of the Planck constant and with the frequency of electromagnetic radiation. EQ, photon energy is equals to H into F, which is Planck's constant and F is the frequency of electromagnetic radiation. F is equals to, we know that it depends on the velocity of light, C by lambda. What is C? C is the velocity of light and lambda is the wavelength of the electromagnetic radiation. That means this photon energy is equals to H into C by lambda. That means the wavelength of the electromagnetic radiation is inversely proportional to the forbidden gap. The wavelength is depending on the is inversely proportional to the forbidden gap. Characteristics of LED. See here, different colors are depending on the different semiconductor materials and their dopant levels. That means mainly this the wavelength of radiation. And this cathode current is increases when the forward forward voltage is increased. The important characteristics of the LED is color. In the starting use of LED, there is only generally initially there is only red color. As the use of LED is increased with the help of semiconductor processes and working levels on the new materials for LED, the different colors were formed. Here, what is the cathode current? The current flowing in this image, and it depends on the proportional to the forward voltage. What are the applications of LED means? Generally, everywhere we can find LEDs as an indicator. It is used as a bulb in the homes and industries. The LEDs, now these LED bulbs also we can find in the homes. LEDs are used in the motorcycles and cars. These are used in the mobile phones to display the message. Alright, as the traffic light signals, LEDs are used. And that means now in our daily life we can find the LEDs almost in all the at all the times. What are the advantages of LEDs? See, it is a tiny device. With this, that means the cost of LED is less. And by using this LEDs, the electricity is controlled, and the current electricity can also be controlled with this. The intensity of the LED differs with the help of the microcontroller. Next one is a liquid crystal diode. It is also a special type of semiconductor. See how it is. We'll see a liquid crystal. The name it is a type of diode, and the material here is it contains a liquid, and it is how it is means it has a liquid and also a crystal, solid material and also liquid material. An LCD is a thin flat panel display device used for electrically displaying information. Generally, we will see the LCD displays. Some of the televisions also these days are LCDs. And notice boards, these are all previously there are LED displays, but nowadays these are LCD displays. Right? And uh, this LCD, it is a display device used for sorry, here I wrote it as a diode, but I'm extremely sorry for this. Here it is a liquid crystal display. It is a displaying device. I'm very sorry for it. It is a display. It is used for electronically displaying information such as text, images, and moving picture. Generally, if you to display anything, we can use these displays. Here, you see, when televisions, that means televisions are displaying the movies, pictures, as well as there is the in the notice boards means it displays the text and images. This LCD is used in computer monitors, televisions, instrument panels, gaming devices, etc. Polarization of light is used here to display objects. And this liquid crystal display is composed of several layers. How it is means it consists of several layers, which include two polarized panel filters and electrodes. LCD technology is used for displaying the image in a notebook or some other electronic device like mini computers. These displays can be used to image. Like is a displaying this way, so you can use whatever we need to display. Light is projected from a lens on a layer of liquid crystal. The combination of colored light with the grayscale image of the crystal forms the colored image. How it is displaying the colored image means this combination of colored light with the grayscale image of the crystal. Formed as an electric current flows through the crystal forms the colored image. This image is then displayed on the screen. Types of LCD displays. Generally, how these LCD displays, there are different types of LCD displays. Mainly, these are classified into two: dynamic scattering display and flat effect display. And there are two types of LCD displays: dynamic scattering display and field effect display. Now, what is this dynamic and what is field effect means? The dynamic scattering display is energized, the molecules of energized area of the display become turbulent and scatter light in all directions. It emits the light in all the directions. Consequently, the activated area takes on a frosted glass, appearing result in a silver display. The display is in a white color, silver color. Field effect LCD contains front and back polarizers at right angles to each other. That means this field effect contains two polarizers. Without electrical excitation, the light coming through the front polarizer is rotated 90 degrees in the field. Generally, we can find the two types of LCD displays. One is with black background with the silver display, and that means white display. And another one is background is of light white background, and with the image text is of in the form of black. That is dynamic scattering display and field effect display. See here the construction of LCD. Here it is a field effect type. It has a mirror and a glass filter. Here is a glass filter and negative electrode. This is the liquid crystal layer, and a positive electrode. Here there is a negative electrode and here there is a positive electrode, and again there is a glass filter. This is the displayed image. Displayed image. This is the glass, cover glass, and polarization film. Here is a polarization film. This is the glass filter. After that, there will be a polarization film. There are two polarized plates. A field effect LCD contains front and black polarizers at right angles to each other. Here there are two polarizer plates. This is the first one, the rear one, and this is the front one. Front that is front and back. Two polarizers with right angles to each other. The basic structure of the LCD should be controlled by changing the applied current. That means based on the applied current, the structure of the LCD will be changed. We must use the polarized light. The light will be in the form of polarized. The liquid crystal should be able to control both of the operations to transmit or can also be able to change the polarized light. This liquid crystal controls both of the operations to transmit the light as well as also be change the polarized light. As already we discussed, two polarized glasses pieces filter in the making of the liquid crystal. The glass which does not have a polarized film on the surface of it must be rubbed with a special polymer that will create microscopic grooves on the surface. See, it has two polarized glasses. We have the glass which doesn't have a polarized film on the surface. It should be rubbed with a special polymer. With that rubbing, it creates a microscopic grooves at the surface of this polarized glass. These grooves must be in the same direction as the polarized front films. Now we have to add a coating of pneumatic liquid phase crystal on one of the polarized filters of the polarized glass. After that, there will be a pneumatic liquid phase crystal. It needs to be coated on this another one of the polarizing filters. The microscopic channel causes the filter layer molecule to align with field filter orientation. And the right angle appears, already we know that it contains two polarized places, right angles. This right angle appears to the first layer piece. We should add a second piece of glass with the polarized film. The first filter will be naturally field polarized as the light strikes it at the starting stage. Thus, the light travels through each layer and guided and the next with the help of the molecule. The molecule tends to change its plane of vibration of the light to match its angles. When the light reaches the far end of the liquid crystal display substance, it vibrates at the same angle as that of the final layer of the molecule vibrates. That at the far end also, the vibration of the light is in the same angle as that of the final layer of the molecule vibrates. The molecule vibration right there also same angle with the vibrations. The light is allowed to enter into the device. Only the second layer of the polarized glass matches with the final layer of the molecule. See, when this light is allowed to enter into the device means the second layer of the polarized glass matches with the final layer of the molecule. Then only this light will be allowed. What is the working principle of LED means? Now, what is the principle means here? When an electric current is applied to the liquid crystal molecule, the molecule tends to untwist. We know that the variation, there will be a motion in the molecules that means tends to untwist. This causes the angle of light which is passing through the molecule of the polarized glass and also causes a change in the angle of the top polarizing filter. This variation in the molecules causes the angle of light, and this causes a light which is passing through the molecule of the polarized glass and also change in the angle of the top polarizing filter. As a result, a little light is allowed to pass the polarized glass through a particular area of the LCD. That means whenever an electric field is applied, there will be a variation in the molecules. With this, the light is allowed to pass through the polarized glass through a particular area of the LCD. Thus, the particular area will become dark composed to others. The LCD works on the principle of blocking light. Here, the main thing is blocking of light. While constructing the LCD, a reflected mirror is arranged at the back. Here you can find the mirrors. At the back side, there will be a reflected mirror. An electrode plane is made of indium tin oxide, which is kept on top, and a polarized glass with a polarized film is also added to the bottom of the device. The complete region of the LCD has to be enclosed by a common electrode, and above it should be the liquid crystal matter. The second piece of the glass with an electrode is in the form of the rectangle of the bottom, and on top another polarizing film. There will be two polarizing films. The second piece of the glass with an electrode in the form of the rectangle or another polarizing film. When there is no current, the light passes through the front end of the LCD. It will be reflected by the mirror and bounced back. When there is no current, when there is a current means it is passing. Whenever the electric current is applied, the liquid crystals will be, the molecule will be changes its shape. When there is no current, the light passes through the front end of the LCD. It will be reflected by the mirror and bounced back. As the electrode is connected to a battery, the current from it will cause the liquid crystals between the common plate electrode and the electrode shaped like a rectangle to untwist. Thus, the light is blocked from passing through. That particular rectangle area appears black. There is a light when the light is blocked from passing through it, the rectangular area appears in form of black. Applications of LCDs, generally liquid crystal thermometers, optical imaging. Nowadays, we can also find many applications for these LCDs. Optical imaging, LCD crystal thermometers, and the liquid crystal display technology applicable in the visualization of the radio frequency waves in the wavegates. We can also these LCDs can also be used in the wavegates for visualization of the radio frequency waves, and also used in the medical applications. Advantages of LCDs. What are the advantages means? Compared to LED, the power consumption of LCD is less. LCD and also compared to CRT. CRT cathode ray tube also is used to display the images. We all know, we know that this CRTs, we can find the CRTs in the nowadays is in the CROs, but in our previous days, in television also there will be a cathode ray tubes. LCDs are consist of some microwatts for display in comparison to small milliwatts of LEDs. And the cost of it is also less compared to LED. The cost is more, but generally the LCD's cost is less. Provides excellent contrast. LCDs are thinner and lighter when compared to CRTs and LEDs. What are the disadvantages? Means requires additional light sources. The construction already we have seen. It requires polarization, coated, and all this. It requires additional light sources. Range of temperature is limited for operation, and there will be temperature limit. Low reliability. Reliability is very low compared to LED. Speed is very low. Speed of operation is very low. That means it needs to. It has many steps to process to emit the light. LCDs need an AC drive. However, is required for LCDs. These are the disadvantages of LCDs. And okay, with this, I'm going to end my session. What we discussed in the session is mainly LED and construction of LED and LCDs, and also we discussed the topic that is called photovoltaic cell. What are the questions we can expect mainly is explain the principle of photovoltaic cell, and also from the LED topic we can expect the question, explain the construction and working principle of LED, and LCD, explain the construction and working principle of LCD, and sometimes in the short answers what are the advantages and disadvantages of LCDs, and what are the applications of LCDs, and mention different types of LCD displays. All these questions we can expect from these topics. Okay, thank you. With this, I'm going to end the session. Thank you.